How come you didn't find other people's YouTube videos showing a service panel actually being installed? Well, because it takes a lot of time. I took that time for you. Unlike the other fuckers here on YouTube, who do this shit for a living and really know what they're talking about and can give you a better understanding of what's going on than I can. The panel being installed is an exterior surface mount overhead service panel. I will try to show some things about installing other types of panels, but it will not be the same as actually seeing it done. My apologies for all the text that's in this video. Basically, Corel Video Studio Pro, yeah, right, is a shitty program. So what you're left with is a lot of text that you're going to have to read. So you can't just like sit back. Order of operations. Decide whether you want to do a permitted job or an unpermitted job. Decide whether or not you even want to change out the whole panel rather than add a sub-panel. If you want to not get a permit, then it could be dangerous. If you're going to do changing out of hot wires, you are going to make sure you use a non-conductive ladder, wearing some extraordinarily non-conductive gloves like high-voltage electrician's gloves. Those are, I don't think you want to do anything less than that. Disconnect one conductor at a time. And as you disconnect that conductor, make sure that there is no way that the conductors can contact anything that's conductive, so seal them the fuck off. You could easily die during any point in this procedure if you create a path to ground from a conductor, so it's real serious. Anyway, disconnect one at a time, and then change out what you need to do, and put it back up. Reconnect one at a time, always making sure you do not create that path to ground. Additionally, you don't want to have a smart meter because they're going to figure out that you're disconnecting power. So you got to take time and opt out of the smart meter process for this operation. If you're doing a permitted job, get a permit. You call the power company, request a designer. Designer will come out, tell you if they want to change anything, give you some advice. They don't know everything about the job. Like, for instance, my designer thought that the power would be disconnected in 1 to 2 days, but it took 2 weeks for them to disconnect the power for me to start work. And, yeah, proceed, and then call your inspection in, have the inspector come out. When it's approved, then in my area, it automatically goes to the power company, and the power company will then reconnect the power, and of course wait a few weeks, of course, again, which is fun, and then you're romex exit points that are located here. We don't know what exactly is behind this box, so we don't know if there's big old wide open gaps or not. Currently they lack cable clamps. Cable clamps will accommodate 2 romexes. We've got 10 gauge wire feeding this electrical panel, which is inadequate, and we got all 12 gauge here. What we could have gone with is we could set up a sub panel here and not have to pull a permit and change the box. But in my case, there's a number of considerations that went into actually getting a permit and changing the whole box to a breaker panel. If you've got an interior service panel, then you're going to have wood framing probably all around the panel, and there's going to be holes cut where the wires go through, and this panel is going to be fastened through the sidewalls to these wood things. And if you're upgrading, then the panel's probably going to be larger in size, so you're going to have to deal with those wood pieces. You're probably going to want to take a Sawzall with a metal cutting blade and then sever the nails, assuming they're nails, not screws. Sever the fasteners that are connecting the cross beams there. It'll be really difficult, so have fun with that. So for the panel change out, we're going to not only change out the panel, but we're also going to change out the weatherhead. It's actually against code if you're using an 8-foot ground rod to have an 8-foot ground rod with a protrusion. Inspectors actually expect the protrusion and prefer it, but they don't want a whole lot that's actually protruding because they want mostly the 8-foot going into the ground. It was actually quite easy to put this ground rod in the ground. In other circumstances where you have bedrock, not hard pan, but bedrock, you're going to want either a serious like post driver, which may or may not work because your bedrock might be real stone that will be difficult for this steel rod to penetrate. It's copper coated, but it's a steel rod. You can go on YouTube to find a ground rod installation, and if you find it by hand, you'll note. Please take note that my soil is even softer than that, and it barely even required water to lubricate the rod. The rod is really designed to penetrate soil. It's kind of amazing how easily it can go down. However, if you do have bedrock, what you want to do is do a U for ground. At least enough concrete to encase the rebar and protect it from the elements. You also want at least enough concrete to cause that conductivity. So if you want to play on the safe side, go 12 by 12 inches of concrete in a 20-foot line at least below whatever your frost line is. And do not use epoxy-coated rebar, I imagine, because I imagine it's not very conductive. So if you really want to go with a good piece of rebar that's going to be resistant to decay over time, you can go with a stainless steel rebar, stainless clad rebar, or a galvanized rebar, which are all hard to get a hold of. Good luck with that. Sometimes they allow copper in your concrete. However, copper does react poorly with concrete over time, and it probably, well, it's a hit and miss whether or not it'll be approved as your grounding conductor. So the ground rod is a good idea. They also sell 10-foot ground rods at Home Depot for like $26, but this was $12, so I went with that. And it's pretty much guaranteed approval in my area, especially with the soil type. The soil is pretty conductive. There's a huge variance in the conductivity of your soil. And I have already removed a branch that is 25-30 feet in the air because that was asked of me. The order of events was basically to call the utility company, request an advisor or designer to come out, and they're degreed people who understand electricity a bit and know what to do in certain circumstances. And the designer will tell you if they're going to use the old conductor. In this case, that's an 85-foot line that causes a lot of pull at the pole, and it's kind of a bad idea, and they aren't going to want to spend the money on trying to do that 85-foot line. In this case, the designer wanted to go directly across and tie in to that line, so they required me to cut the tree to pass their inspection, so I did cut that tree, and they'll probably tie in right there. And they handed me a booklet showing me the weatherhead and service panel installation instructions. I'll show you that just now. After much talking to people and asking a bunch of ridiculously difficult to get responses questions, online turned out to be the source of actual information I could go by. I can't run the wires through here. So that changes the plan a lot. I've got to run those two circuits into this box somewhere, and the only real good place to do that is right up at the top here above the bus bar. So if I'm going to use this panel, then I got to make sure that if I do go through there, I meet all the height requirements for breakers and the meter socket. So this panel is not going to work for this location if I don't want to use conduit. So I'm going to go to Home Depot, get another panel. Woohoo! And I'm going to try to return this one. Jesus. Well, fortunately Home Depot let me return it without the box. It comes with a freaking pack of breakers. That's a good ass deal. 320s and a double 20. See these knockouts back here? They are just under 2.5 inches on center, and they measure about 7/8 of an inch. And then we've got these here, which happen to measure about 7/8 of an inch, and are just under 2.5 inches on center. So, I'm just going to knock those out. No drilling required. I'm going to return my drilling tools. This is not going to be easy. Gotta pull these 1/2 inchers off and put some 1/2 inchers on. Gotta make the wires real close together to make it happen. Boy, that's tight. I'm gonna go slow and gentle. All the metal shavings, you don't want any metal shavings in there. These lock nuts have a cone shape to them. You want to have the cone shape facing the electrical box so that when you tighten it down, they actually dig in to the electrical box. There's a special tool you could buy for tightening these, but oh well. Now we still have to be careful when we put this up on the wall. Ideally you'll have a second hand to help you out. And I think I just might go buy a second hand. Somebody to help me out. I don't have a helper around who's willing to go on camera. I'm going to try to one-man this panel on here. Feeding the wires through. I got my drill nearby. Oh, by the way, you need a 1/4 inch of romex jacket coming through the hole minimally. And apparently inspectors don't want to see much more. Now, there happens to be a wood board directly behind this, so I can screw directly into that board, and I can get away with that. I want to hit the stud, though. I've got a stainless steel self-tapping screw, fortunately, so I'm not going to be splitting a whole lot of wood putting this screw in there. I'm leaving it loose. We got a 400 amp service panel here. The meter socket is here. The wires connect way up in there over to this main breaker. The current travels through this massive set of aluminum plates, ultimately to this copper plate, to these aluminum thingies, and there's another set of aluminum blades that come out and are electrically insulated from these ones, but come out every other one from this hot wire. So the hot goes through a circuit breaker, and the wire that's on the other side of the switch circuit breaker is connected here, and it goes all the way out throughout your house. And then when you plug in a device and you turn it on, that turning it on allows electricity to continue to flow back through the neutral wire and ultimately into this bus bar. If it's a main panel, then you can use this bus bar, and these two bus bars have to be electrically tied together. If it's not a main panel, then generally these two bars will remain separated. There will be a main lug that transfers the neutral back to whatever your main panel is. You might take one of these lugs, put it over here on the ground bar, and then have that separately transfer the ground back to whatever back to your main panel, where they ultimately get tied together and sent down to the ground rod. This is a big fucking breaker. I wonder how much is this worth. So when you hook up a 240 volt or 220 volt breaker into this thing, it clamps on to these two blades. And since these switch, the two blades are connected to both hots. And the difference in voltage between these two hots coming from the transformer is 240 volts. So that makes your 240 volt circuit. So ultimately, these two lines connect, one here and one here. And ultimately, those two lines connect when this switch is on to here and here. And you're going to have generally a black and a red color, although you can use whatever non-white, non-green, non-bare color that you want to. They come out of here, and these two wires go through your device. And so the difference when the current is allowed to flow from here to here, then it'll make 240 volts. Voltage is basically like electrical pressure. Specifically, it is the measure of energy of each electron, whereas amperage is the number of electrons passing by any cross-section of a conductor per unit time. And wattage is the product of those two. But the difference in voltage between the bus bar, what we call the neutral, and either one of these hots is 120 volts. No matter what blade it's attached to, whether it's this one, whether the blade is connected to this hot wire, or whether the blade is connected to this hot wire. Ultimately, these 110 volt circuits transfer back into this bus bar. Then the difference in voltage here between either one of these two possible connections is 120 volts. So that's how you get your 120 volt circuits. The slots that the breakers fit into will correspond to these knockouts. So you're only going to want to take out as many knockouts as you have to in order to let the breakers actually push through this cover panel. Any open spaces that you're left with be replaced with these little cover panels. They just snap into place from the front. Any holes that you have that have wires coming through that don't have clamps on them, and the wires, if the wires aren't coated in their own metal protective casing, you'll have to have a bushing. And the bushings are designed for each different little hole size in your panel, and they pop into place as well. Used holes will require cover plates. The thing that makes an exterior box exterior is basically the way the sheet metal work is done. It helps keep rain out of the circuit breaker panel. Inside, and it's not quite level, and it's not getting level with me, not getting exactly level with me wiggling around. So I'm going to reposition this screw. The 3 screw holes we're going through stucco. So I'm going to pre-drill with a masonry bit through the stucco. Alright, that went through. Got this waterproof washer here. I'm just going to take the washer off, actually. They come right off on this box. Not a very quality adhesive they use. Okay. Alrighty. If you have an old house like this, it might be hit and miss that you're actually going to contact wood behind the stucco. These walls happen to be 3/4 inch planks, but there's big gaps that make it suck. So all these penetrations need to be sealed. And I believe that these metal washers, or these rubbery washers, are considered sealing according to the box manufacturer. Oh, additionally, all of your screw penetrations need to be caulked behind the wall. So now that I have all my penetrations marked, I'm going to take the box off. I'm going to use a silicone caulk, and I'm just going to shove it everywhere. The areas where we really need to caulk are right here. Just jam it in, fill it up, and then leave a mound. Nobody's going to see it except the inspector. And then again, the inspector might not even check, but you're supposed to seal all of the screw penetrations prior to putting the box on. You're not actually supposed to seal around the box. You're supposed to leave a 1/4 inch gap at least between the wall and your box, so that heat that's generated by the electricity running through your service panel can be dissipated through the back as well as other areas. Time to put this box back up. It's not required by code because they will accept those ghetto-ass washers, but I don't like them. He might have me tear this out, I don't know, but whatever. He might have me remove the caulk, I doubt it. He might actually like it, we'll see. He being the inspector. Okay, and then later I'm going to caulk up this hole. Now remember, we're not going into studs on these other screws, so we can't use this impact to its fullest without stripping those screw holes. So the next step is to clamp down these wires. Thank goodness there's a square drive receptacle in these screws. This isn't tedious. No. I'm going to get the grounds together. Take care of those first. They usually want you to put this on multi-strand wiring using a brush, because the brush helps push it in there. I'm putting the wire through so it doesn't actually touch the other side. But you can see it protrude. I mean, maybe you can't see it, but the inspector can see it. The wire protrude through the bar. I'm going to push these down as I go. Since this is the main panel, the whites and the grounds go on the same bar. Now I'll loosen up the bottom 4 screws. Not the Phillips on the bottom, but these ones with the square drive. And again, I'm putting these through far enough that you can see copper on either side of the bus bar, but not touching the other side. I'll tighten these by hand later. Now it's time for the breakers. Slots in this panel. And I want future upgradability. I'm using these double breakers. There's a bracket in there. And yeah, okay, they're preloaded with, well, this one's preloaded with grease. Breakers will have different attachments, so you need to find breakers that are suited for your panel. So you might just like buy a few breakers, which aren't generally very cheap, and see what fits. But with the breaker pack that comes with the breaker panel, you can take one out and bring it to the store and find equivalent looking ones. Now, for the 110 volt branches, you can have double throw that's fit into a single spot or single throw. These are more expensive, however, you can fit more shit in there. And so with my space requirements, it's definitely advisable to go with the double throw.
You don't have to shorten the wires, but you can, just a little bit. It's probably a good idea, because then you're starting with much less oxidized copper. Everything wears out. So oxidized copper is like a worn out copper surface that you'd ideally, well, either take a good sandpaper that doesn't leave sandy residue and clean off that way, or just slice it. Start fresh. The ground wire to this ground rod. And it appears I'll be using this one at the edge, this knockout. And I'm going to be using the small knockout, the 1/2 inch. The edge of the hole is 1 inch in, and this wall is irregular. So I'm gonna bend the tube a 1/2 inch, and I'm gonna write that down, write myself a note, that the offset for the IMC, not the EMT, you can't use EMT exterior, is going to be 1/2 inch. Your main ground wire doesn't have to be as thick as your primary conductor wires. I forget what's required for 100 amp, but pretty sure this is adequate for 200 amp. Box came with a bag that contained a ground lug, so we gotta pick a spot on the bar for the ground lug. There's 2 holes, the big hole and the small hole. Small hole has the screw go through it. Okay, that's on there pretty good. Okay, now there's a little issue here. You don't want to cover up the screws. Box, but now, one thing I did learn that I didn't show you is that the grounding rod has to be added to the current ground system, in this case, the plumbing pipes. determine two things about the masthead. One is if I need to secure the masthead to the roof. In the configuration that fits within specifications for, well, having adequate height above the road and above all areas. And also how long I need to cut my masthead to. So I'm going to use this piece of PVC. It's vertical. And it goes down to just above where the threads bottom out in this socket up here. That's how long the pipe's going to be. However, it's going to be another inch, taking into account for the thickness of the roofing, plus the 30 inches that I want it to go up. So I will measure to here on the PVC pipe. That is 40 inches. 40 inches. Plus 30 inches is 70 inches. So I want a 70-inch masthead, if that's going to work. So I'm going to write that down. As I scroll across, it's like right there. It's hard to see. It kind of sags, and we only get lift about a little more than a third of the way through, like 2/5. It starts to lift up. So this line is not going to raise a whole lot until it actually hits the driveway there. Yeah, that's an issue. I have the attachment mechanism in the center of the pole, and a new job across the street has indicated that that is what did occur over there, but it is not necessary. I'm going to pretend that that 30 inches is from the top of the roof. So I'm going to put 2 extra inches. So we'll just get a little extra height there, and then we'll get a little extra height by raising the point of attachment higher than they would prefer. I want to show you what ultraviolet radiation does to plastics. And these are plastics that are meant to be exposed to ultraviolet radiation. I'll be using this. And time to get cutting. Never done this quite before, but to remove this attachment point from this other pole. I happen to know that this bracket is rated for 2 inches down to 1.5 inches. The weatherhead. And I got this magnetic level attached to it, and I'm putting it in line with the gridded receptacle on the top of the electric box. I'm looking for a place where it's level. And so I'm eyeballing it, and I already have a marker up there to tell me where the level point is. And now I need to get a hole saw that is slightly larger than the pole. And the clearances are real tight. You can see the edges of this. We had hardly any to work with. You want to wear safety glasses. And then looks like I'm about 1/2 inch away from the edge of the wall. And I got a recess over here, which brings if the wall was flat, I'd do 1/2 inch out, but the wall's not flat. And I'm putting the hole right here. Sorry, I gotta get in your way here. Not going to be easy. You want the hole saw to face straight up. Okay, when you're going up to the shingles, if you have ass-poop dingles, aka asphalt shingles, ass-poop dingles is the correct pronunciation. You want to be real gentle when you're pushing up with this hole saw so you don't just tear everything up. Hopefully you'll make a clean hole. This is a roof jack. It's found in the same section as the weatherhead pipes at Home Depot. And it's made of shitty steel. It's bullshit. Is probably going to have some holes. You have to buy separately a flange with holes that match up to that pattern. On an overhead service panel, these holes will be on the top of the box. On interior service panels, there won't be any holes like that. It's going to have a certain diameter, so you get the diameter of the hole of the flange based on the size of the pipe that you want to run. And the size of the pipe you want to run could have to do with what you happen to have in your backyard, in my case, or just what you would prefer to have on the outside of your building. Usually it's 1.5 or 2 inches. It should come with a foam thing you can use on the bottom of this to make a weather-tight seal. But if you don't have the foam thing, then you can just shove a bunch of silicone caulk in there. As long as it's watertight, it's good. In the case where none of your bolt holes match up, you can drill a big ass hole and put one of these on there. I don't know what it's called. It's not too expensive, and it's got a plastic liner so that your conductors don't scrape against anything metal. That's nice. And it's got a rubber gasket in here. The rubber gasket's going to go on the outside, and then you just tighten it down with big pipe wrenches or something. So we're doing a 100 amp panel, and we need 2 gauge for that. I'm going to straighten out the ends. To have 3 feet of wire coming out the weatherhead for the utility company to hook up to. I'm going to mark one white on both ends. And I'm going to mark one red. White neutral wire, which connects to the center of the transformer coil, is going to go on this lug right here, and it's going to connect to this bus bar. Oh, the type of wire is not standard THHN. It's like XHHW or something. It's designed to be more UV and weather resistant than THHN standard. It's not commonly purchased except for like these weatherhead installations and stuff.
What's up, man?
Okay, now because we're having copper contact aluminum, we want to put this Noalox compound on. Put a generous amount in there. And then you want to brush it in with something that's going to penetrate in between these copper conductors. This is a brass brush. It's not doing the best job, but it's getting in there a little bit. Dude, amazingly, like, there's some people with all the tutorials like don't show actual like a box being removed and a box being put back up there.
Yeah.
Hopefully you have gloves. The inspector's going to want to see copper on both sides. And he's going to want to see the Noalox on there. I'm just going to give it one more squirt for good measure. It would help if I had a sharp blade. Now these things tend to work themselves loose, so I'm going to give them another tighten. We're doing some clamps. I don't know what the clamping schedule is for the ground wire conduit, but figure 2 clamps is good. Okay, and my wall is obviously not flat. So I want to get these clamps centered over the pole so that the 2 holes are equidistant from the wall on each clamp. Okay, including that clamp up there. Within 30 inches of the box, I need to have a clamp. Additionally, within 30 inches of the roof, I need to have a clamp. So this one clamp satisfies both of those conditions. And I've got that equidistant as well. What I've got to do is measure the distance on each one of these. And there's some play in this pole. on the bottom here. That's 1 inch there. 3/4 of an inch is good. 3/4. I'm gonna text myself that and go cut some non-wood, because I hate wood. I absolutely hate wood. Non-wood backer plates to go behind those. Because these clamps, they really aren't that strong, and they won't hold their own without a backer plate behind them. You'll see. And I have pre-drilled the holes in the stucco and put some screws through in, which would show past the sheathing. I went up into the attic and checked for penetrations, and at this screw point there is a 2x4 that a real bolt can go into, and then at this point I need to reinforce it with a 2x4. So I'm going to go up in the attic and add a 2x4. Here's a bit size that is skinnier than the shaft of the bolt, or at maximum equivalent diameter to the inner diameter of the bolt. Plexiglass. Really don't know if that's a great decision, but I know it doesn't rot like wood. Making the holes line up. Okay, that's pretty solid. Now I'm going to call it in for inspection. They circle that it's a number 79 type job, and they give a number to call when it's ready for inspection time. And it's automated, so it just might be open on Sunday. Now the device you're looking from is the device I need in order to call the thing, so you can't see me call. Okay, I called in the permit. I called in for an inspection, a final inspection. And I believe they give me a second opportunity on the house if I fail once. And the failure should be accompanied by instructions as to what all to change. And last time I had an inspection, the inspector really liked that I brought a clipboard and was genuinely and in a not casual manner interested in writing down all that he had to say. Alright folks, looks like the final approval is in. So this was frickin' approved, baby. Oh, yeah.